Didn't realize I was on mute. This morning we're going to do just a quick review for test 6. I know we haven't had a real class this week and thought I would just kind of give you a review. Very basic, keeping it short, keeping it sweet, kind of giving you the topics and maybe a few questions to focus on that I know have been tough for students in the past. Give me just a minute on my home computer, so it's a little weird to get everything set up. Okay, so now we're ready to go. Let me. So the main thing is the test is open. It opened, today's Thursday. It opened Thursday at 8 a.m. It'll be open Sunday till midnight like all the other tests. And let me think. It doesn't have a lot of questions. I can get into the number of questions here in a minute, but it really only focuses on 3 sections. 7.5, which is rationalizing the denominator section. 7.6, which is solving radicals, and then 7.7, which is I just used a really pared down section about imaginary numbers. So let's look and see what you need to focus on the test. Let me flick over to the document camera. Okay. I'm gonna get this test. Yeah, so 7.5 was rationalizing the denominator, right? So, you're going to have a single denominator, and then you're also going to have a denominator with 2 terms. So a single denominator question might look like this. Like if we had, let's say, 3 over 10, let's say the square root of 3 over 10, something like this. And then if it's a single, radical, we need to break it apart into the numerator and denominator. And then to rationalize it, remember we just multiply by the square root of the denominator on top and bottom. And we wind up with the square root of 30 over the square root of 100. And the square root of 100 is just 10, right? So we wind up with the square root of 30 over 10. So we've rationalized the denominator. There's no radical on the bottom. And if it's a single denominator, a single term down here, that's all you have to do with the square roots, right? You just multiply by the square root of 10, or the square root of really whatever is under the radical in the denominator. We know how to do that one. And then what if we have 2 terms? So let's say we had 4 over, let's say, the square root of 2 plus 5. So if we were going to do this one, look, notice we can't divide anything out to begin with. There's 3 terms, but we can't divide anything to all 3. So you're going to multiply by the conjugate. So we've got the square root of 2 minus 5 on top and the square root of 2 minus 5 on bottom. When you do that, I'm going to leave that factored on top just in case it simplifies at the bottom, at the end. I don't know why I put that does not have a square root, okay? Just in case the 4 factors out in the end. And what will happen down here, because you're multiplying by conjugates and you have a square root, you're going to wind up with a number, okay? So let's FOIL this out. So first I do the square root of 4, or square root of 2 times the square root of 2. This is square root of 4. Outside I get minus 5 square root of 2. Inside I get plus 5 square root of 2. Those should always be opposites if you're multiplying by conjugates. And then minus 25, right? Negative times a positive. So on the top, I'm left with 4 square root of 2 minus 5. On the bottom, okay, these cancel. This is just 2, right? So 2 minus 25 So that's going to be a negative 23. And I'll tell you what's going to happen is the book and I mean, any math text is not going to leave a negative in the denominator. They're either going to move it out front or move it to the top. So let's just do that. So I'm going to say it's read here, negative 4 square root of 2 minus 5 over negative 23. There we go. And there's an example. Now look, I'll tell you there's a few different single terms and a few different two terms. So it's not just that there's one question in each, but these are good examples of both. Okay, that will be on the test. And then 7.6 was on solving radicals. So there's so solving radicals. So if we're going to solve a radical, there's really kind of an easy solve and a harder solve. Let's look at an easier solve first. So 7.6. Solving radicals. If we had, like, let's say the square root of 3x minus 1 plus, actually, let's not do that one. Ooh, I lied. Square root of 3x minus 1 minus 4 equals 0. So remember, when you're solving an equation with a radical, you've got to get the radical by itself. So you got to isolate the radical. So you get the square root of 3x minus 1 equals 4. And then you're going to square both sides. So you get 3x minus 1 equals 16, right? Add the 1. Now you're going to solve for x, right? 3x equals 17 and divide the 3. So you get x equals 17/3. Now you got to be careful though and make sure that this is the actual solution, because we just have to check our answer. If you plug 17/3 in, so if we had, this is me just checking it. 3 times 17/3 minus 1 minus 4, is that equal to 0? Well, the 3's cancel. So you get the square root of 17 minus 1 minus 4. Yeah. 17 minus 1 is 16. Square root of 16 is 4. Minus 4 is 0. This checks out. Okay. So therefore, this is the solution. So this is kind of the easier solving, because really the reason is we don't have like two separate radicals and a number. Okay. There's not two separate radicals in a single number. So let's look at one that really turns into more work. Hold on. Come on. Okay, maybe this one will work. I'm just trying this off the top of my head. So that x plus 7 minus 5 equals x. Okay, we'll see what happens when we do this. If it doesn't work, if we get a crazy answer, that's fine. But I'm going to show you at least the process of how to do it. So again, we're going to isolate the radical. So we wind up with x plus 7, add the 5 over. So you get x plus 5, right? When you move the 5 over. And then to get rid of the square root, you're going to square just like you did before. And on the left, you're left with x plus 7. On the right, you have to FOIL this out. Do not tell me it's x squared plus 25. That's a really common mistake, but that's just not true. And actually, I'm going to write it out like this: x plus 5 times x plus 5. So when you FOIL this out, you get x squared plus 5x plus 5x plus 25. So you wind up with x squared plus 10x plus 25, right? So the radical's gone, but it leaves us with a trinomial. So now we're going to solve this trinomial by factoring. So I've got a positive x squared here, so I want to leave it. I want to move these two things to the other side. So I'm going to subtract x and subtract 7 from the other side. So I get 0 equals x squared plus 9x. Is that plus 18? Oh yeah, this factor. So then we're going to factor this trinomial. It's the easier factoring, right? Because x squared is by itself. So we end up with x plus 6 and x plus 3. Set each one of those equal to 0. You get x equals negative 6. This is old stuff, right? This is section 5. I think it was 5.7 or 5.6. Man, it's been a while. But if you wanted to look up from here down, this is a totally different section that we've covered in the past. So you might want to go back and look at it, because I'll tell you, there's going to be one of these like this on the test. Now, in the end, though, you've got to check it. If we put in negative 6 up here, I'm going to do this in my head. Negative 6 up here, that would be, actually, I can't do this in my head. So let's check negative 6. The square root of negative 6 plus 7 minus 5. We want to know, is that equal to negative 6, right? Because that's where the x's are. So we get the square root of 1 minus 5. And I want to know, is that equal to negative 6? Well, no, that's 1 minus 5. 1 minus 5 is not negative 6, right? It is negative 4. So you know what? That one's just not going to work. So let's try negative 3. Negative 3 plus 7 minus 5. We want to know, is that equal to negative 3, right? So this is going to be the square root of 4 minus 5. Oh, yes, it didn't work, right? 2 minus 5, that equals negative 3. So the solution would just be x equals negative 3, okay? So there's going to be two like that. One that's more of a basic solving, like that previous example, and then one that's more complex like this, where you have to, it turns into a factoring question. And then lastly, it's just simplifying imaginaries. And I just did simplifying radicals that are imaginary, right? So if we had, let's say, the square root of negative 25, this is 7.7 now, guys. Just that little thing I did on 7.7. Square root of negative 25, that's just negative 5, right? Or, oh my gosh, it's not negative 5. It's 5i, right? It's 5i. Remember, we said that taking the square root of a negative was non-real. It was. Now we're actually going to write it in the correct notation. So if we had one like, let's say, the square root of negative 40. Well, I like doing the factor tree on this one. I'm going to say, well, that's 20 times 2, 10 times 2, 5 times 2. It's a square root. So therefore, I know I'm going to take out an I. But I can take out a 2, I have to leave a 10. So I'm going to have 2i square root of 10, right? Pair of 2, so the 2 comes out. I comes out because this is negative underneath, right? And then 5 times 2 is left over. That's where the 10 comes from. So let's do another one. Let's say we had something out there already, like negative. Square root of negative. Let's think. I don't have a calculator in front of me, so it's hard to make one of these up off the top of my head. Now let's say 56, negative 56. So again, it's a square root, so I know it's going to create a negative. There's a negative already out there, so really that's like a negative 1 times the square root of negative 56. So I've got to break down 56. 56 I know is what? 7 times 8. 7's prime, 4 times 2, 2 times 2, right? So I've got a pair of 2's here, and then we've got a negative, and then there's a negative here. So really, this negative on the outside is from the negative that was already there. I'm going to take a 2 out, and then I'm going to take an I out. What's left over is 7 times 2, so 14. Boom, I've simplified that completely. Okay, so if you want to go back in that 7, 6, 7, 7 lecture, you'll see more of those, and definitely in the homework you see more. But if you want to email me about that, you're more than welcome to. But that is a good review for test 1. Okay, that's a good review for test 1. Let me come back to me. So Let's think next week, or this is our last regular test. So this is test 6. Once we get that done, next week we're going to focus on solving quadratics, and then really focus on going into college algebra. I'll tell you the next 3 or 4 3 lectures really are probably the most important when it comes to college algebra. And it's nice that we're doing these at the very end of the semester, so we actually transition well into college algebra, the second 7-week college algebra class. Okay, so I'm looking forward to that. I'll give you more information about college algebra. I know I said that I'd do that last week, and I've kind of dropped the ball on it. But if you guys have any questions or concerns, let me know. Get that test done. I think that's it. If you have any questions, just email me. Hopefully I will be in my office on Monday. I just feel like I have better home field advantage when I'm at the office, and we won't have to just watch pre-recorded lectures. Okay, I'll see you all. Have a great day. Have a good weekend. Hope